All right, let's take a look at lesson 1.6. I'm going to start here on this packet. Excuse me, I said 1.6. I meant 1.7. We're going to go right from 1.7. It's going to review 1.6 and specifically things that we might not have had time to hit in class that I wanted to get to. But the process is going to be here for this bell ringer. So number one on your packet looks like this, just one problem on the page. It says given F, G, and H right there, those three equations, find G of F of H. So last class, when we were doing composition of functions, that's what this G of F of H is. When we were doing that, the thing I told you is basically the lesson in a nutshell is knowing how to substitute. If you can substitute properly, you can solve these problems. So here's what I'm going to write out. Here's the technique I use. Whenever I'm trying to find G of F of H, I stack the equations. So we'll have G stacked. So G's equation is x squared minus 1. And I stack it on top of F, which happens to be 3 divided by x. And then I stack that on top of H. I know last class, we did not see three equations together other than the ACP question. But I'm going to stack accordingly like that. All right, from here, if I'm going to find G, what's going on? There we go, of F of H, we do substitute. Which way do we substitute? Do we substitute going from the top and work our way down, or from the bottom and work our way up? Bottom up, good. And the other thing with substitution is I recommend substituting with parentheses, unless, in this case is the unless, you have like a square root to represent the parentheses. This time, I'm not going to use a parentheses because the square root itself will kind of count as this parenthesis. So I'm just going to substitute straight up. So what I'm about to find here is what we would call F of H. F of H, right here, F of H would be equal to, and now you remind me with substitution. Think of athletics. If we were going to substitute, option 1, do both the original and the new player. The original player and the new player get to play in the game? Or does one come out and the new player replace the old? It gets replaced. Okay, so the most common misconception I see when I teach composition is that students, when they go to do this step right here, they'll substitute in and they'll leave the original X. And so they'll have like the X out front. Don't do that. With substitution, one comes out, one goes in. So that is right there, F of H. Now we're not supposed to only find F of H. We need to find G of F of H. So now what do I do with this portion? Very good, Olivia. We substitute this into G. And so this equation right here is going to get substituted into this X right there. And so that would create G of F of H. All right. So when I substitute in, I have this equation here. I'll write it in purple. I will substitute this one in parentheses since that's not all contained in one symbol. So I'll put it in parentheses. 3 over the square root of x plus 5. And then I'll continue on with G's equation, which was to square the x, so square that parenthesis, minus 1. This I can simplify. So with the squaring of a fraction, I know with COVID, a lot of us missed some of our algebra 2 in particular. When you go to square a fraction, it's very simple. You square the numerator by itself, you square the denominator by itself. So question, what is 3 squared? 3 times 3 is 9. And then when you square the denominator, what is the square root of a square or a square of a square root? What happens to those two symbols when you have a square root being squared? Okay, that's a good idea. Specifically, I'm trying to ask how are the operations related to one another? A square root and a square. How are they related to one another? Let me change it this way. Okay, I distribute the square through, if you will. So they're both squared. How does this square root relate to the square there? The word I'm looking for is it starts with an O, rhymes with opposites. They're opposites. So what's going to happen here is the square root and the square will cancel one another. So I'm left with x plus 5 in the denominator and a minus 1 on the outside. That would be my solution right there for g of f of h. That is g of f of h. Let me sneak that in. G of f of h of x would equal that right there. So that's our number one. Now let's take a look at number two. Number two asks, find g of f of h of 11. What do you think we'll do different this time, having 11 at the end instead of an x in the parenthesis? So the previous problem had an x. This time I have 11. What do you think is going to happen this time that's different? We'll use the 11. The question is, where do we use the 11? If I remember right, this is x squared minus 1. Yeah, x squared minus 1. F is 3 over x. And then h I saw was square root of x plus 5. Where do I use the 11? Gabriella says, let's use that 11 at the bottom. So what you do is when you have a number, you just add that in as like another stacked equation, but I'll put the 11 directly under the x. So when I substitute in, question, will that become 11x plus 5? Or will that become 11 plus the square root of 11 plus 5? Which one's correct? The left square root or the right square root? Which one did I do this correctly on? The right, because the rule is we substitute. So this x comes out and it's replaced by 11. So we're looking at the right. That's the value right there. And I can simplify that. Any idea what the square root, or let me ask this, what's 11 plus 5? 16. Does anybody know what the square root of 16 is? 4. So that right there is going to equal 4. What do I do with that 4? This one substitutes an equation above into the x. And so what will that equal? 3 over 4. Okay, now what do I do with that 3 over 4? What do I do with this? I can't divide 3 over 4. Or it'll just be 0.75. I'll just leave this 3 over 4. So it's simplified. What do I do now? Same thing. So by same thing, I agree. Someone on that side of the room, they said we should do the same thing. What do they mean by that, you think? Substitute. Substitute where, Jason? In the x. You got it. You know the process. You substitute that into the x. And so we would have 3/4 or 3 divided by 4 squared minus 1. And so to solve this, again, when you square a fraction, it's like doing the numerator squared and then the denominator squared. What is 3 squared? 9. Good. And what is 4 squared? 16. And then we would subtract 1. I'm going to combine, or excuse me, I'm going to get a common denominator. If you remember that, how to get a common denominator is you would need both sides to be 16. So if I'm going to add a division of 16, I need to also multiply because you got to do the opposite so they cancel. So basically what I'm going to do here is I'm going to have 9 minus 16. What is 9 minus 16? Because that's multiplying. 1 times 16 becomes just a 16 there. Let me erase the 1 so you can see that just becomes a 16. What is 9 minus 16? I heard it, -7. Good. And when you add or subtract fractions, the denominator does not change. So the answer would be -7 over 16. That is g of f of h of 11.
How do we insert on the now fraction?
A slash.
Yeah.
A slash. Yep. Hey, question for you. That was great. That's Power School Learning. We should open that up. and go to lesson 1-7. Chapter 1, and then 1-7 near the very bottom, and it's number 3. We're in class work right now. If you open that up, and then yours will probably say start this exam. Yeah, when you click that on number 2, you'll just type it in with a slash. So you would type in -7/16 there. What was I going to ask? Oh, I'm going to make a key observation. Here's the second most frequent mistake I see. So the number 1 mistake is students don't remember to take out the X. They substitute leaving in the X. The second is this. Whenever you have a number, what I see a lot of students do is plug in 11 to every single X. Did I plug in 11 to every single X? Only into the very first X. Then after that, you do your math and then plug in the new number. And so that's how you get your answer there for number 2. And I'm going to click on pre-calculus. From there, we're on lesson 1-7. So I'm going to chapter 1. I'm going to scroll down to 1-7. On 1-7 and the digital resources, I'm going to hit the Desmos pre-programmed graphs, and I'll just hit this. I'm assuming you're going to want to also open up the lesson to submit your answers. So I'll go ahead and click that, start this exam. So that'll be open, but then I'm going to right click on this Desmos pre-programmed, and I'm going to open that as a new tab so that I can have it over here. This is called composition. That's actually mathematically the name for that, the G of f of h. They call that a composition, and that's graph number 4. So if you click that, now what it's going to do is it's going to graph this in order G of f of h. I need to go back and pull my equations. So my equations were 3 over x, 3 divided by x. G is x squared minus 1, x squared minus 1, and h was the square root of x plus 5. I think I'm going to take a look again just to make sure I have the right equation. Square root of x plus 5. That's correct. So I have these in. Now, to make sure I get this right, it tells there's an important note right here. And it says by default, it's f of g of h. Is that what we actually found on this problem? F of g of h? Okay, so you need to switch the order. So right here, it says to edit the order of the function, change the composition below by the purple circle. That's talking about this. We need to have the letters go first G, followed by F, followed by H. I'm going to zoom out a little bit so we can see the domain. Does this graph go forever? So I'm in G of F of H now. Does this graph go forever to the left? No, that gets a vertical asymptote. Well, let's see what X value that's approaching. So I'm going to zoom in. What X value is this approaching? X value now, not Y. -5. So that means it comes from -5. Does it go forever to the right? Yes, it does. It goes forever to the right. So from -5, forever to the right. Different question. If it's approaching a vertical asymptote, will it ever actually get to -5? No. So I'm going to use a parenthesis. So my domain would look like this. The domain would look like parenthesis -5 to infinity. Now that's from the graph. If you're wondering, why is it that we had that given our answer? Here's what you would have to do. When you do domain with compositions, you have to do domain on each step along the way. So with the square root, what are you not allowed to have on a square root? A negative. So on the square root stage, if you're not allowed to have a negative, what happens is you start with the solid dot shaded to the right. That's how you start. And if we solve the inside, you would end up subtracting a 5. I'm going fast here, but for the sake of time, I'm going to go fast. We would say the inside has to be greater than or equal to 0, meaning shaded to the right or equal to 0. We subtract the 5 because algebraically you do the opposite. What the math you see, it says x plus 5. So I'm going to -5 to isolate the x. And we find out that x has got to be greater than or equal to -5. That's where that -5 comes from. But when we go to the next step, when we plug this into the next step, what are you not allowed to have with on division? When you come here, you're not allowed to equal 0. So what happens to this? Let me change this now to a -5. That's now at a -5. What happens to the closed dot if you're not allowed to equal 0? becomes open. I'm gonna see if I can click in the middle, and make it open. No, didn't work. So I'll retry it. It now becomes at this step open circle. And that's why our domain became there. Will this affect the domain? A squared and a -1. I'm asking the wrong question because I only got one answer there. What are the two things you look for that can change your domain? Division of x and the square root. This step, does it have any division or any square roots? So that will not change the domain. These two steps did though. The square root eliminated negatives. The division eliminated the actual value itself. And that's why you have it approaching an asymptote, a vertical asymptote there, or an infinite discontinuity, as opposed to a closed dot. All right, so that was compositions. Now let's take a look at inverses. Inverses. Quick thought. Just throw out your best guess. If you were going to try to describe inverse in one word, what word would you use? I love hearing opposite because it's totally wrong when I get to correct it. Opposite is what almost all students say. And opposite, I want you to think of as a negative. A negative is opposite. What's the opposite of 5? -5. An inverse, what it does is ultimately it's the equation that if you used it together would give you a linear function. If you put them together, would give you the function y equals x. So really what it is it takes the equation to y equals x. That's the inverse. That's not the opposite. So 5 and -5 are opposites. Negative means opposite. Inverse is what gets you back to x. So there's an easier way of describing it. And the way to describe it is to switch x and y. Do you on your packets have the slide here, vocabulary? No. So we're going to write it on this slide then. This is the first one you have. It walks you through a horizontal line test when you get there. And here's the reason why. I want you to write inverse up top. Inverse definition. Switch x and y and solve. Switch x and y, then solve. Now, on this slide, it says horizontal line test. That is not the test you usually hear. What's the test you normally hear? Vertical line test. Any idea why would this slide say horizontal line test? Because you switch your x and y. Brilliant, Jade. If normally we do a vertical line test, kind of like the y-axis, if you switch your x and y, the y becomes a x, and now what direction is it? Horizontal. We will use a horizontal line test to determine if the inverse is a function, because the new equation will have switched x and y's. So what do you use if you're just looking at the original function and you want to know, is what I'm looking at a function? What type of test do you use? I want to clarify here.
Oh, the vertical line.
The vertical line test. So all your life, when you've heard vertical line test, that's when you're like looking at the actual function. What if you want to know if its inverse was a function? What do you now use? Horizontal, because inverse means do what?
Switch x and y.
Switch the x and y's. Okay. So, and by the way, this is the symbol for it. This symbol right here, if you want to draw that in, that's the symbol for an inverse function. Inverse function. If it's a function, they will use that symbol. So only if it's a function, we'll use the F, because F stands for function there. All right. It says graph this function and determine using graphing calculator, apply the horizontal line test, determine whether it is an inverse function, if its inverse function exists. There will always be an inverse. It's just a matter of, is that inverse a relation or is it a function? So here's the first picture. Does this pass the horizontal line test? No. So what does it mean about its inverse? Will its inverse be a function or its inverse be a relation?
Inverse will be
Inverse will not be a function.
so when you switch it.
I'll explain in a second. The inverse will not be a function. So what do we call it if it's not a function?
A relation.
Inverse is a relation. Okay, so the question is, why is the inverse not a function? So the graph itself, let me ask this, is this graph here F, is f a function? Does it pass the vertical line test?
Yeah.
Yes. So f itself is a function. That's the equation right here. I'm going to point at the top arrow. F here, this equation, that is a function. It passes the vertical line test. So f is a function. Its inverse will not be a function because if you test with the horizontal line test, does it pass the horizontal line test? No, it fails. So the inverse will not be a function. It'll be a relation because it failed. I can do that, BC, because it failed the horizontal line test. And I'm going to abbreviate. I'll write it one time. Horizontal line test. The rest of today, I will say HLT, horizontal line test. Okay, let's look at the next graph. Here's the graph. First question. This is a new graph for f. Is f here a function or not a function itself? Would this pass the vertical line test? Yes, this would pass the vertical line test. So f is a function. What about its inverse?
No.
It's also a function.
Yeah.
It is also, it's very tricky to see in this picture. It's not a good graph. I need to just replace the graphs with Desmos. This would have an inverse function. So I want to write on here inverse passes, or f passes the HLT. Therefore, what's true of the function? If the graph itself passes the horizontal line test?
It's inverse.
That's right. The inverse is a function. And I guess I could write, whoops, on the previous note, the previous slide, we could say because it, let me be more specific than it, because f on this one, f failed the horizontal line test. I'll make the notes better there. Okay, on part B, again, it's a bad picture, but truthfully, this is always going up like that. It's always increasing. It passes the horizontal line test. Okay, you have one. I'm going to graph it up here for you. I just need a blank graph, so I'm going to delete these crazy letters, and it should give me a blank graph, my URL there, and I'll let you take a look and make up your mind. 3 divided by x minus 1. Here's your picture. I'm going to let you think of if that passes the horizontal line test. So the question you're asking yourself is, does this pass the horizontal line test? Answer. All right, so here, these are textbook steps for how to find the inverse function. So it says first, determine whether it has an inverse. We're going to do it no matter what, whether it's a relation or function. So I'm not going to use step 1. Step 2, it says replace f of x with y, and then interchange x and y. That's when I talk about switching x and y. I think it's easier. This step is telling you switch your x and y. Switch x and y. Then it's going to say solve for y. And that's what I wrote down earlier. Switch x and y, then solve. That's step 3. Step 4 says restrict the domain. We will do that as we go. Okay. So really the algebra is 2 steps. It's to switch x and y, then solve for the y. And that's just finding an inverse. So my rules, I find an inverse, whether it's a function or a relation, doesn't matter to me. We're going to do the algebra to solve for it. If you want to determine it's a function, then yeah, do step 1. All right, here's our first equation. It says determine whether f has an inverse function. So let's go ahead and do their step. Would this pass the horizontal line test? This passes the HLT. What does HLT stand for? So that means f will have an inverse. We will have an f -1. Oops, f, that's not. F -1. We will have an inverse. Okay, so if you were going to do so, step 2 on their previous slide, which for me is going to be my first step. So if you hear me say step 1, what I'm talking about is to list this as y and then switch x and y. So here we go first. According to the textbook, second and third step is I'm going to switch. I'm going to have x equals y over 2y minus 1. So notice I switched every y. Well, there's only one y. I made the one y an x, but both x's became a y. So that is, in my opinion, step one. Switch X and Y. In my opinion, what is step two? Solve for Y. So when you have multiple Y's, the way of solving for multiple Y's, it's just like an algebra solving when you have multiple powers, is you're going to have to factor at some point in time. I'm going to walk us through how to do that. I'm going to first get rid of the denominator because I do not like working with fractions. So I'm going to multiply by the denominator here. So you can cancel factors. You're not allowed to mathematically cancel terms, but you can cancel factors. So factors multiply and divide. I'm going to multiply by the denominator. That's going to get me, when we distribute here, what's 2y times x?
2y.
And I always distribute going to the right. I never distribute backwards. I will change my letters though to be alphabetical. So I'm gonna make it 2xy. It's the same thing as 2yx, but I'm gonna do alphabetical order. And then what is -1 times x? Negative x. That's going to equal y. Now the trick for inverses when you have two y's is to get to GCF. What does GCF stand for? Greatest common factor. So what is shared that I'm going to factor? I don't want to factor the x. That's not what I'm trying to solve for. I want to solve for y. So what I'm going to do is anything that has a shared y, I'm going to move to the left side of the equation. And anything that doesn't have a y, I'm going to move to the right side of the equation. So I'm using the term move, but that's not a mathematical term. Now let me ask for the mathematical term. If I need to isolate this 2xy, how would I get rid of a minus x? I need to do the opposite. What's the opposite of a minus x? So I'm going to add x to both sides. And I'm going to do a second step in one here. That is true. We're going to add x. I need to get this y to the left side. So if I was going to move it, I need to do the opposite mathematically. Y is being added to x. What's the opposite of adding a y? So we're going to subtract a y. And we combine like terms. When you combine like terms, you can only combine if your variables match up. This is an xy, that's a y. They do not match up, they need to stay separate. So I'll have 2xy equals, no, I'm sorry, 2xy, I forgot the minus y, equals x. I'm going to give you a chance to look at that. And I'm going to go ahead and clear that so I can extend my page. I'm going to give you a chance to look at that and see that ultimately what I have here, I have not canceled anything out. All I did is rearrange the negative x and the positive y to the opposite sides of the equation, which means that sign switched. So this positive x became a negative y, this negative x became a positive x when they moved across the equal sign. Sorry, I pressed the wrong button there. Let's let this load again. Okay, I want to, no, I clicked the right button that time. I clicked arrow. Why did it do that? Let me see if it'll, there we go. Had a little rain delay there, taking us forever. Okay, now that I move that. The trick, when you have two y's, how do you make two y's become one y is you're gonna use GCF. What does GCF stand for? Greatest common factor. What's shared between these two? Y. So if I divide out the y, what is 2xy divided by y? 2x. And what's a negative y divided by a y? -1. Very good. -1. And now you probably see to get y by itself, I only need to do one more thing. Mathematically, that y is multiplying with the parenthesis. What is the opposite of multiplication? Division. And you know what's very frustrating about this problem? We did all this work, 2x minus 1. And when you look at your final answer, as compared to the original, I'm going to rewrite this not as y equals, but as f -1 of x equals. That means inverse function. I have the exact same equation I started off with. That does not happen very often, but in this case, it was exactly the same thing. Isn't that kind of frustrating? Yeah, if you do all that work, you at least want a new answer, make you feel special. We got the original answer, and then that's, it says on this problem also to state any restrictions on the domain. Will this be all reals?
No.
Ah, great answer. I heard yeah and I heard no, but I heard more no's. So I said great answer to the no's. Why did I say great answer? What are we looking at if we say no? Division. What are you not allowed to divide by? 0. So the way to solve this domain is it's going to be all reals except for what gives us 0 in the denominator. You're not allowed to divide by 0, so it's going to be all reals except for that 0 right there in the middle. We're not allowed to divide by 0. It can be, we can divide by negatives. We can divide by positives. We would just have to determine what that number actually is. In the end, it will not be 0. So I take my denominator, 2x minus 1, and the symbol is does not equal 0. And now we do our algebra, which in this case happens to be algebra 1. To isolate this x, do I need to divide by 2 first or add 1 first? We add 1 first. And now, second step, I have this 2 in front of x. What does it mean if you have a 2 next to an x? Add, subtract, multiply, divide. What's happening? They're multiplying. What's the opposite of multiplication? Division. If I divide by 2, I find out that x cannot equal 1/2. That is our number right here. The domain is all reals except for 1/2. If you look at the picture, you can see it goes forever left, it goes forever right. There's just one little bitty gap in between these two pieces. And mathematically, we just discovered that gap where the two pieces do not touch each other. The gap in between those two pieces is at x equals 1/2. That's its restriction on the domain. Okay, let me make a different observation for you. I'm throwing out a lot of information. I understand that, but I need to do that in math to get us through. If the domain is x cannot equal 1/2 on the inverse, do you know what that means about the original function's range? The original range is that y cannot equal 1/2. Now, why would that be the case? Because the y's and the x's switch. So the range of the original function became the new the inverse's domain. So up here, y would not be able to equal 1/2. This is the graph f right here. This is the graph f. This is now f inverse. I know the equation is the same, but I'm just showing the picture. If the x could not equal 1/2, that means over here, y could not equal 1/2. Okay, so let me ask this question one more time, just to make sure you're processing this. Forget this equation entirely. You have two new problems. You have its function on my, what does this look like to you, my left side?
That's your right.
It is my right, but from how y'all are looking, does it look left? Okay, over here on your left, you have the original. Over here on the right, you have the function. If on the left, the domain is x cannot equal 3, what's going to be true of the inverse? Y cannot equal 3. If on the right, you have y cannot equal 0, what's going to be true over here? You are getting it. Okay, one more. What if on the left, the original, the domain is x has to be greater than 0? What's going to be true of the inverse over here in the right? Y has to be greater than 0. Why is that always the case? Because you're switching x and y. That's all that's happening mathematically, is you're just switching x and y. So you're switching, another way of saying it, instead of switch x and y, is you're switching domain and range. You're switching input and output, x and y. That's all you're switching, okay? Y'all come on quick there. Let's try part B. Let's get a different answer this time. Man, I feel like I'm talking a lot. I need a drink or something here. This problem here, who remembers algebraically, what's step 1 if you're going to find it? Oh, back up. Let's do textbook. Textbook says determine if the inverse will be a function. Does this pass the horizontal line test? Yes. So F passes HLT. If it passes HLT, what will be true? That what will be a function? Inverse will be function. Good. Okay, so now get to the algebra. What's algebra step 1 to find the inverse? Replace the x and y. So f of x represents y. So it's going to be x equals 2 square root y minus 1. So that's step 1, switch x and y. What's step 2 for algebra purposes? Solve for this y. Okay. What comes first? Do I need to divide by 2 or do I need to square first?
Square.
I hear that. When you solve, you actually do opposite of PEMDAS. When you're isolating, You do opposite. So I'm actually not going to square first.
Divide by two.
I'm going to divide by 2 first. So whenever you're isolating a variable, you do not follow PEMDAS, you do the exact opposite. And I'll prove it to you on a more basic problem that comes up. Okay, now, what would you do to get rid of a square? I said that backwards, didn't I? What do you do to get rid of a square root?
Square.
On the video, I'm going to edit that out so I look like I'm perfect. Just kidding. Some of you who watch the YouTubes know that's not accurate. I have plenty of mistakes in there. I had to correct myself frequently. All right, so we square a square root. That's the opposite mathematically, the opposite mathematical operation. Those cancel. We talked about this earlier. What do you do when you square a fraction?
You just square both of them.
Square the numerator and square the denominator. 4 equals y minus 1. Last step. If you're isolating the y, we add 1. So if you want to leave them separate, you'd have x squared divided by 4 plus 1 equals y. When I rewrite this, since we said it is a function, I'm going to write it as f negative 1 of x. That just means f's inverse. That's what that symbol means. F's inverse is x squared over 4. Oh my goodness. Y'all didn't correct me. What did I do wrong here?
You got that
Put the
one.
word.
I'm going to edit that out as well. Just kidding. Bad joke. Okay. I won't tell that one again. There's our answer. Now, here's what's weird. I'll give you a chance to write this. Put your thinking caps back on. If you only had this equation, what would you think the domain is? I see a division, but there's no x down there. So 4 can never be 0. So I never can divide by 0. There's nothing eliminating. So it should be all reals. But did we say the domain's going to be all reals here? No, this domain is going to be restricted. And off of this graph, I can tell it's going to be restricted. You're about to see it here. This should make a full parabola. I'll show you the image. They do a full parabola. That is wrong. That's that graph. But that's not how it should look. What it needs to have is what we call a restricted domain to make it a function. And so when you look at this one, the domain, think of x values. Where does the x value start? What's the first x value on this graph? 1. This goes from, I'm going to do in bracket because it literally touches that point. From 1 right forever. What symbol represents right forever? Okay, and now it's range. This is low to high. How low? So think of y-axis. It goes as low as 0. And how high does it go? Okay, when we come over here, we need to restrict the domain. That means we're not going to look at the whole graph. We're going to restrict domain. So yes, what's the domain going to be? 1 to infinity or 0 to infinity? Restrict the domain. It should be 0 to infinity. And what's its range going to be?
1 to infinity.
1 to infinity. Okay, so their picture is wrong. We need to correct their picture. The domain should start at 0, which that you're looking on the x-axis at 0. That should start right here and go to the right. Cross out this part. That is not a part of the inverse. Now, I'm going to take this time to prove it to you. I'm going to go over to my calculator. If you click this earlier, the Desmos pre-programmed graphs, if this comes up, you'll notice the very next graph, number 5, it says inverse relations and functions. I'm going to click that. I'm going to type in, it says up here, graph the original function as f of x. So I'm going to graph this original one right here. The original is 2 square root of x minus 1. And down here, it says, in case you need to restrict the original. Well, we're not restricting the original. There's the original in blue. You see how it, nope, sorry. The original will appear red, it says. It appears red. So there's your original graph. You see how it's in red? I didn't read the instructions very well. The original's in red. Does that match our first graph? Does the calculator, and the calculator does math right. Does the calculator show the inverse like their picture showed it to us? No, it cuts it off at 0 because the calculator knows to restrict. The graph of the inverse is blue, it says. If you're wondering mathematically, how did you make this happen? How did I program that? I use this right here. After you type in the function, you just type in x equals f of y, and that's how you graph the inverse. Which I'll get to that in a moment. Okay, with that, I'm gonna let you try one. I want you to graph this to see if it exists. I'll graph it to let you see if it exists. So you're gonna look at the red graph. It's going to be x plus 2 over x minus 1. I'll let you determine. Why isn't the red showing up? I got a programming error here. The red should be. I'm going to clear this just for a second. There you go. There's your original graph. I'll let you determine. Will the function exist?
Yeah.
All right. And if it does exist, then you need to solve algebraically for this. Remember, switch x and y. And this is one that mathematically you're going to have to do that GCF. So after you switch x and y, you're going to end up with two y's. You're going to have to end up doing that GCF step that we did on 2a. Okay, so I'm going to give you a moment to work on this problem. All right, at the very start of class, like literally at the very start of class, I said, not at the very start, after the bell ringer, I said, what's going to end up making a inverse? Well, mathematically, what makes an inverse, I told you, is not the opposite. Remember when I said, hey, what's the one word you think of? And y'all said opposites, and I said, good, because I need to correct that. It's not an opposite. What makes an inverse is it means if you took a composition function, that means you put the two together, they end up with an answer of x. X is your answer when you do a composition. And everything else cancels out, and all that's left with is x. That's what makes a composition. So I'll prove it to you. Here are two inverses. These two are inverses. If I wanted to prove it, it doesn't matter if I do f of h or g of f. It does not matter. I should get the answer f, or excuse me, I should get the answer x. That was terrible. So let me try this. I'm going to find f of g. F O G. And I'm using the stack technique. So what I'm finding right now is f of g of x. That's what I'm solving for. So f is 2/3 x plus 2. G is 3/2 x minus 2. What mathematically needs to occur for us to find f of g?
Plug in your x.
What's a better word than plug in?
Substitute.
Substitute. I'm going to substitute. When I substitute, I'm going to substitute this whole equation down here in for what? The x. And when we substitute, if one comes out, something else goes in. So what I will have is 2/3 times this right here that I have 3/2 x minus 2 plus 2. So what I did is in the place of x, I substituted g's equation. That's g right there, surrounded by the bare bones of f when I pulled out that x. That's what happened. So if I go to simplify, this is weird. Normally we'd start with the inside parentheses with PEMDAS. Mathematically, what I'm about to do is just fine. Don't worry about it. But I'm just going to go fast. What is 2 times 3? 6. And what is 3 times 2? 6. So normally we start with the inside parentheses, but ultimately this would multiply, this would multiply. And with multiplication, it doesn't matter the order. So I'm starting with out here. 2 times 3 is 6. 3 times 2 is 6. What's 6 divided by 6? 1. So really all I'm left with is x minus 2. And now that I've done the multiplying, I can take away the parentheses. I have x minus 2 right there plus 2. And what is minus 2 plus 2? 0. So all I'm left with, x minus 2 plus 2 is simply x. That is f of g. So if your answer is x, guess what that means is true about the graphs? This doesn't explain much because I haven't told you. It means they're inverses. So on this graph, the smaller slope is f. Let me highlight that and I'll do it in blue. The lowest slope is the graph of f. There it is in blue, f. Okay, there's the graph F. The graph G had the steeper slope. Remember those words from algebra. The steeper slope is the graph of G. Mathematically, how do you find an inverse? What do we do mathematically? Switch what? Okay, so the line y equals x, where the y's equal the x, should always reflect the two graphs, because that's the point where they equal one another. And since I'm switching one another, they would reflect on that line. Do you see how the blue graph and the red graph somewhat reflect one another along the line y equals x? That y equals x goes right between the two of them. That's because it's an inverse. Where y equals x is where they would be right on top of each other, or the middle of the graphs. That's what that picture is trying to prove. So we did prove that they are inverses because our answer was x. All right, on this one, I want you to do the math. It looks like they're doing f of g and g of f. So let me see if these two, they're not the same. These two are not the same. Go start working first f of g, and let's see if we can get the answer from there. Okay, start with f of g, and then start g of f. All right, here's where I think inverses get fun, is if you're given an image. I think this is where inverses are fun, because if you know what an inverse is, and you tell me what's the definition of an inverse? Switch what?
Switch X and Y.
Graphing can be quite simple. For example, this point, I'm going to take this point and assume that that point landed perfectly right there. What is the value of that point?
-1.
-1, 2, -1, 2. What will be the inverse's point? 2, -1, right 2, down 1. And you can see this weird, I don't know what color that is, pinkish color. It basically hits 2 to the right, -1. And I will do one more. This minimum is by little review here. Is this an absolute or a relative minimum?
Local.
Or local relative or absolute?
It's a relative minimum.
It's local, relative. It's not the lowest point in the graph. This one's at 1, -2, 1, -2. What does that mean about its inverse?
-2, 1.
-2, 1, -2, 1. Notice it has that point. So with graphing, all you do is switch x and y points and then connect your dots. I could have gone a few more points, like for example, the origin. We could have done that. That's the same. Here's one that would be different. This point is 2 to the right, 0 up. So we would have 0, 2 up. Notice that point there at 0, 2 up, so on and so forth. So that's how you can do graphing. All right, you have another one to try. I want you to take your time and try this problem. All right, now let's take a look at example 5. So real world, it says the fixed costs for manufacturing one type of stereo systems are $96,000 with a variable cost. That means a changing of $80 per unit. So basically it costs us $96,000 just to own the land, the building, and hire our employees or whatever. But for every studio we make, there's extra every stereo we make, there's an extra $80 cost. So we just cost to buy more materials, stuff like that. So the total cost making the stereos, and it tells me here that cost is f of x, which means the cost is y. So I'm going to underline that. Cost is y. Notice cost is on the y-axis. And x is stereos, so that's why x stereos is there, is given by this equation. Explain why the inverse of the function f-1 exists. Well, it exists, I can tell you quite clearly, because this passes the horizontal line test. Because this function f, this one's f here, because f passes the, let me write that down, since the function f of x passes the horizontal line test, f inverse, f-1 of x exists and is a function. Okay, so that's the first thing. Then it says find the inverse. That's what f-1 means, inverse function specifically. So what I'm going to do here is switch my x and y. So we'll have x equals 96,000 plus 80y. So if I'm isolating my y value here, since I switched x and y, now I'm going to solve for the y. I'll first, that 96,000 is adding, it's positive, so I'll subtract 96,000. So again, I'm doing the opposite of PEMDAS. Whenever you solve for a variable, you do the opposite mathematical operation than what you see, and you also go in opposite order of PEMDAS, PEMDAS order of operations. So that's why I'm going to subtract first. So I subtract it out, and I have x minus 96,000 equals 80y. Now 80 is right next to y, so it doesn't mean add, it doesn't mean subtract. When 80 is next to y, it means multiply. So the opposite operation of multiplication is division. So now divide everything by 80, and we'll have our inverse. Now I'm going to check to see if I can simplify that, but I know I'll have x over 80. The 0 and the 0 could cancel out. I think, let's see here, mental math. 8 goes into 9 one time with the remainder of 1, so it's like 16. 8 goes into 16 twice. That 0 and that 0 cancel out, so there's still 2 more zeros. I think it's going to be 1,200. I'm going to check right here. Just do a new line. 96,000 divided by 80. Yes, 1,200. Okay, so that is our equation right there. That's the equation. As it looks like, since this domain is all reals in the first quadrant, this the inverses will also be well, I shouldn't say f's. Let's talk about this. Its domain here goes from 0. This is for the f, not the inverse, but f. Its domain goes from x of 0 on to infinity. Its range starts from 96,000 and goes to, oops, I forgot the infinity. 96,000 comma to infinity. So over here, what I can state confidently is that the domain of the inverse is going to be this one's range, because you switch x and y. And since range is the y's, this domain would be from 96,000 to infinity. And the range would be from the original's domain, 0 to infinity, because we switched x and y. This domain becomes a range, this range became a domain. Okay, so now that we've done that, let's look at part B. Part B says, what do f-1 and x represent in the inverse function? So if f of x originally represented cost, and x originally represented stereos, I spelled that right, stereos, there we go, stereos. Well, in the inverse, since we're switching x and y, f-1 of x will now no longer represent cost, since we're switching the x and y, and this is y. This f-1 will refer to stereos, whereas the x in the inverse will represent the cost. And now part C. It says, what restrictions should, if any, should be placed in the domain of f? Oh, I already kind of answered this. So what restrictions? So let me copy what I have here, this, and all that. I copy this. And paste it down here. Okay, since this is the original function's domain and range, we would need to place this restriction on the domain. We're not going to let the domain go for all reals or even from 0. This would be a restricted domain, since we started saying that we have a, no matter what, our original cost of 96,000. No matter what, you have to pay this. I'll say no matter what. So just your taxes, the building costs, whatever, you're gonna have a $96,000 cost, whether or not you make a stereo or not, that's gonna be part of it. So on this restriction, no matter what, since we just said f of x is now referring, sorry, this is, I was looking at the y, threw me off. This is domain is cost. So now this restricted domain right here is referring to the cost. So the cost at minimum is 96,000. And over here, the stereos, well, you could, the minimum amount of stereos you can make is 0. And that would go to infinity, because on the inverse, stereos is the y, which is the range. So the minimum amount of stereos you can make is 0. Now with that being the backdrop, let's get to number 10. It says find the number of stereos made if the total cost was $2,016. So I'm going to use that answer we had earlier.
Please remember to submit your attendance.
And let's, whoops, move this over a little bit. So if we said that on the inverse function, that the inverse is now the stereos, that's now the y stereos, and that the x is now the cost, then that means that whenever, if I'm plugging in here, if the total cost is 216, I would just plug 216,000 there. So f, whoops, f -1 of 216,000 would equal 216,000 divided by 80 minus 1,200. And so I'll type that in the calculator right here. 216,000 divided by 80 minus 1,200, and I get 1,500. That would make 1,500 stereos. And that would be our answer, 1,500 stereos. So now I have one for you to try. Take your time and select the best answer. All right, let's take a look at the ACP. One thing that's very simple on the ACP is that many of the graphs have multiple choice, or I should just say on my test, if you have multiple choice, an easy way of solving inverses is just to cheat. And when I say cheat, I don't mean literally cheat, but I mean use the graphs. So if I open up my graph for inverse, what can be so easy about this problem is I would just type it in. So this says if f of x equals 8x cubed. So I'm just going to type in 8x cubed. Which graph represents the inverse? This tells you the original is red. The inverse, it says right here, is blue. There's the inverse. Which answer is the correct answer? F is the correct answer. So that's how easy inverses can be if you're given a graph. It's just a switch. Now the algebra required would be the same 2 steps. If you want to do the algebra, just as a reminder, you would say x equals 8y cubed. Hang on a moment, we got time. If you're going to solve this algebraically, remember when you're solving for a letter, you do the opposite of PEMDAS. Would I do a cube root first or divide by 8? You would divide by 8. So I divide by 8. Let me change colors here. Sorry. I would divide by 8. And so we'd have x over 8 equals y cubed. And if you don't know this, the opposite of a cube is a cube root. It looks like a square root, but it has a 3 right there. A cube root does not need a plus or minus. Odd roots do not need a plus or minus. So it's just this equation. So now I would have f inverse equals the cube root of this, which another way, what a cube root is it's solving for the number that if you multiply it by itself 3 times gives you the value. Do you know what you can multiply itself by 3 times to get 8? Something times itself times itself, 2. This could be simplified as the cube root of x divided by 2. I simplified the denominator there. That would be the equation right there. And if you graph that, you would see that that is in fact the answer. If I just said y equals, I go over here to cube root. That's not cube root. Where is it? Functions, miscellaneous. There it is. Cube root. Third root of x. All this divided by 2. You can see that that is the correct answer.